In this video, we are going to look at the limit properties, or they're sometimes referred to as the limit theorems. They're a small collection of theorems that allow us to algebraically simplify complex limit problems. And the purpose of this video is simple. It's to simply show you what they are and what they are saying. For all of the properties that I'm about to show you, we are going to use this notation to help us understand what's going on. So we're going to let the limit of the function f of x as x approaches c equal some quantity m. So I want to point out that c is a constant. It's a number like 2 or 4 or 10. It's some value in the x set of values. So it's an element in the x set of numbers. And then for the g of x function, we're approaching the same place, c, and this is equal to n. So these are two distinctly separate functions, f of x and g of x, and we are going to be looking at what happens when we combine them together in a number of ways. The sum law is fairly intuitive. This is the first law that we're going to look at. What we're doing is we're taking the limit as x approaches c of the sum of our two functions, f of x and g of x. And what this thing is equal to is simply the limit, let's get a pen. The limit as x approaches c of f of x plus the limit as x approaches c of g of x. Let's go ahead and look at an example just to make sure that we're understanding what we're saying here. If we look at this example of the limit as x approaches 2 of 2x plus 4x squared, I can approach this by splitting up this giant function, which is the sum of two distinct functions. I can split it up and find the limit of each separate section. So at this point, we can use our knowledge of direct substitution, and we can say, well, I know that this function 2x is a straight line. I know that 2 is in the domain here, so I can plug it in, and I'm going to get an answer of 4. 2 times 2 is 4. Same exact argument follows here. 4x squared is a parabola. It is not discontinuous at 2. It is continuous at 2, so I can plug this value in and get 2 squared, which is 4 times 4, which is 16. So now notice that to do this problem, I did not need to use the limit properties. I could have gone back here and I could have said, well, 2x plus 4x squared is a continuous function. Excuse me. So I can still solve this by simply taking 2 and plugging it in and getting the same answer of 20. So I show you this not necessarily as a shortcut, but simply as an observable truth, an observable property regarding limits that you should be aware of. All right, the product law is dealing with multiplication, the product of two functions. So I can identify one large function, in some cases, as the product of two distinct functions, f of x and g of x. So in this case, we're going to use the same logic, and notice that this will be the limit as x approaches c of the first function multiplied by the limit as x approaches c of the second function. Again, this should be somewhat intuitive. If this is equal to m and this is equal to n, the conclusion is that it equals m times n, or mn. The third one is a quotient law. Quotient is a fancy way to say fraction or multiplication problem. And we're going to have to make a condition here because we can't divide by 0. So we're going to just make sure here that n does not equal 0. So we're going to look at g of x. G of x is going to be in the denominator, and it can't be 0 because we can't divide by 0. And here's what the quotient property says. If we have the limit of the quotient of two functions, f of x divided by g of x, it equals the limit of the top function divided by the limit of the bottom function, which in our case is m divided by n. Now again, this is particularly useful if we know this function and we know this function separately, and we can then combine them in this way. A lot of times, I just want to reiterate that a lot of times this property and all these properties aren't necessarily shortcuts, but these are things that are that are properties, meaning that they're always true. So I don't teach you this as a way to be sneaky and fast, because frankly, direct substitution is going to be your friend for most of problems that you will see that you could be using these properties for. All right, this last one is pretty handy. It's the constant multiple property, and it says that if you have any number or any constant k could be pi, it could be 2, it could be -7. If you've got the limit of that constant multiplied by your function, you can pull that constant out in front. So you're pulling this k out front and multiplying it by the limit of f of x as x approaches c. The limit of f of x we've let equal m, so this would equal k times m.